Hello everyone. Welcome to today's presentation on threesome problem in Python. So the threesome problem requires identifying all unique sets of three numbers in an array that sum to a given target value. So for example, consider the array here, that is -1, 0, 1, 2, -1, -4. Suppose if we want the target sum is 0, so what are the three numbers, unique triplets, that whose sum is going to be 0 in this array? Suppose if you consider -1, 0, 1, right, this sum is going to be 0. So that set is nothing but this. So if you consider -1, -1 and -1 and 2. So this set, right? This set also turns out to be 0. So both satisfies the condition. So our goal is basically to find out such a kind of unique triplets out of the given array. So let's understand the problem. So, the basically the problem takes an array of integers and target sum. So our task is to return all unique triplets in the array that adds up to the target. So it's crucial that the triplets are unique, meaning no duplicate sets should be present in the output. Handling duplicates is a key challenge. So additionally, the array may contain a mix of positive and negative numbers, which adds to the complexity. Therefore, our solution must be optimized for both time and space to handle large data efficiently. So a naive approach is, there is a brute force approach is using a three nested loops that would result in order of n cube time complexity. So which is impractical for large arrays. Hence, we need a more efficient strategy. So the steps involved in the algorithm are listed in this slide. So first one, what we need to do is, step one is sort the array. That is, so it basically sorting array enables us to use the two-pointer technique and simplifies the duplicate handling. And the second step is iteration through array. So that is, we iterate through the array, fixing one element at a time. For each fixed elements, we aim to find two other elements that together sum up to the target minus the fixed element. So when it comes to step three, now we are, so after step one and step two, right? Now within the step two only, there is a step three, there is a two-pointer technique. So here, by initializing the two-pointer, one starting just after the fixed element, the other at the end of the array. So we can move them inward based on the current sum compared to the target. This method ensures we cover all possible triplets without redundant computations. Okay, and step 4, to maintain uniqueness, we skip over any duplicate element. This ensures that each triplet is the result set is distinct. So overall, this approach actually brings down the time complexity to order of n square, so making it feasible for larger inputs. So let's understand through logic, through implementation. Okay, so this is a threesome problem. So what it takes, basically the array and the target sum. Okay, in the first step, as we discussed, the first step is the sorting. So we have to sort the array. So that is going to enable us, help us to use the two-pointer technique as well as the duplicate removal. Okay, now this for, right, this is going to help us to traverse through the array and also helps us to use the two-pointer approach. So this is the first element. Out of three elements, we are fixing one element. Okay, and this I greater than 0 and this one, right, this step is basically to avoid duplicates. That is, we check if the current element is same as the previous one. If it is, we skip to avoid duplicate triplets in the result, right? So that is present element, if it is equals to the previous element, we'll try to go to the next element. That's what continue does, right? Now we need to initialize the pointers. That's where it does. Yeah. So for each fixed element, that is the nums of I, right? We set left to I plus 1 and right to last element of the array. That is the nums minus 1, the length of nums minus 1. That is the rightmost of the array. Now, we need to calculate the current sum with the those left and right elements. So this nums I is the present element, and nums left and nums right are the those two the triplets what we are trying to find out, right? Now we try to find out current sum by using these three numbers. That is the nums I, nums left, nums right. So if the current sum is equal to the target, we found the triplet, right? So in that case, we have to add it to the result array, which we initialized. Okay. Now, after that, what we need to do? Now, we need to find out other elements as well, right? Are there any other two elements that can be added to the current element that results in the same target? So we need to increase the left by +1 and right by -1. We have to decrease the rightmost pointer. Again, so here also, when we are increasing left and when we are reducing right, again, we need to find out whether are there any duplicates with respect to these these values. That is the nums of left, nums of right. So if left is lower than right and the num left is equals to num left -1, then the left is again increased so that we can avoid the duplication. Similarly, the right one, we need to check the current and the rightmost. Okay. So in this case, right has to be reduced by 1. So similarly, now what we need, suppose if the current sum is not equals to the target sum, the current sum is lower than the target, then what we need to do is we need to increase the left by +1, because if the current sum is lower than the target, that means what? So we can increase the number. So that means we have to increase the left pointer because it is already sorted in the ascending order. Okay. Similarly, if it is greater, then we have to reduce the rightmost one. So that is the one we are able to find out this one. So the main crucial steps, right? You have to check the current sum if it is equal to the target, sorting, two-pointer approach, and the current sum equal to the target sum. So we have to check the condition. If it is equal, then append the result and check for the duplicates. If it is not equal, the move the left or right pointers. So and similarly the time complexity, the sorting actually which is outside of the loop, which is n log n, and the main algorithm within that for loop and two-pointer technique contributes to order of n square. So the total time complexity is order of n square. Some of these two things is nothing but order of n square only. So similarly the space complexity irrespective of the array size, always that is we are trying to append k is the number of triplets. It's like order of k only, right? So yeah.